In this video, let's see how we can issue a token on XRP Ledger. For that, we need to follow a couple of steps, and the first step is to enable rippling on issuing address. We can enable it by enabling a flag called default ripple. We have already seen how to enable and disable a flag, so we need to enable rippling on issuing address. That's the first step. And the second step is to establish a trust line from another account to the issuing address. Now we haven't seen it, but we will see it in this video to establish a trust line from another account to the issuing address with the help of a transaction type called trust set. And the third step is to send the tokens to the second address from issuing address. Now wait, you may be thinking, where are the tokens to send, right? But that's how it works. First you enable rippling on the issuing address, or any address for that matter, and then establish a trust line with that first address, and then the first address can send the tokens to the second address. I'll show you the code and the detailed working of it in this video, but this is the brief overview. And one more thing, the first address, that is the issuing address, and the second address usually belongs to the issuer itself. Okay, the first address is called the issuing address, and second address can be called as operational address or something like that, but usually these two addresses belong to the issuer itself. Okay, and there is another step which is optional, by the way, that is black hole the issuing address, which means just disable the master key of your issuing address and set the regular key to an R address which doesn't have a secret to it, which basically means you lose control of the issuing address. Why do we even need this? It's actually important for a couple of things. The basic thing which people look for is the issuer doesn't issue more of those tokens which you are holding, which dilutes the value of the token you are holding, right? And there is also one more feature wherein an issuer can freeze the trust line, that is, freeze the trust line with some customer for regulatory reasons. And if the issuing address has been black hole, that is, no one has control over this issuing address, that means the trust line can't be freezed. So that brings some more sense of security to the customers. And the main thing being the issuer will not be issuing more of those tokens which the customer is holding. That's the main intention of black holing the issuer account. I want to confess one thing. Initially, I didn't want to do this video because the ecosystem is already filled with a lot of tokens which basically do not hold a lot of value, or some tokens which do not hold any value but just empty promises of building utility and stuffs like that. Once they sell their token, they are nowhere to see. But then I felt like with great power comes great responsibility. So the great platform that is XRP Ledger, we as developers should take the responsibility to build something worthwhile out of it. And I know a lot of developers do a good job with it. So I thought a couple of shitcoins in the ecosystem shouldn't discourage developers with good intentions. So I thought, well, let's go ahead and make this video. So let's dive in and learn what is issued currency first. So this document I'm showing you has all the regulatory stuffs like KYC and AML requirements and stuffs like that. Please go through it in detail. It's not enough if you just learn how to issue a token. You need to know the regulatory stuffs behind it. So with that said, let's read a couple of things here. All currencies other than XRP can be represented in the XRP ledger as issued currencies. And I call these currencies as IOUs or tokens preferably. They are tracked in accounting relationships called trust lines between them. So let's see, what is the accounting relationship? To understand it, we need to understand what is rippling. I'll take a simple example and try to explain the concept of rippling. So let's get started by reading this. Rippling occurs when more than one trust line is adjusted to make a payment. For example, if Alice owes Charlie $10 and Alice also owes Bob $20, then you could represent that in the XRP ledger with trust lines like this. Now consider this scenario. If Bob wants to pay $3 to Charlie, and then he could say, hey Alice, take $3 of the money you owe me and pay it to Charlie. Now Alice transfers some of the debts from Bob to Charlie. In the end, the trust line works out something like this. Just take out $3 that you owe to Bob and shift it to Charlie. Now the trust line look like this. We call this process where two addresses pay each other by adjusting the balance of trust line in between them as rippling. This is a useful and important feature of XRP Ledger. Rippling occurs when addresses are linked by trust lines that use the same currency code. Now this is important that these two addresses must be linked by trust lines that use the same currency code. Well, this will be clear once we start writing the code. And rippling as a whole is not this simple sometimes. There will be multiple paths with rippling, with multiple accounts which has rippling enabled. So please go through this page, this document, link to which will be given at the end of this video tutorial. So go through this documentation wherein they have given a little bit complicated examples for rippling, wherein multiple addresses have rippling enabled. That means there are multiple paths for a payment to travel. Okay. You can go through all these complicated examples. For this tutorial, a simple example of rippling is enough to understand the concept. So that's it. So let's assume this is the issuer, and this issuer has thousands of trust lines from thousands of addresses, and they all pay each other, which means balances on the trust lines gets adjusted. Okay, let's see that in action. But before that, let's look at a documentation which has separation of roles concept. I think it's present in issuing and operational addresses. Let me check that. Yeah, that's it. This is recommended separation of role. Not that you have to follow, but it's recommended. Okay. So you will always have a issuing address, which is also called cold wallet. And you will have one or more operational addresses or hot wallets. These operational addresses are always connected to the internet. That is, your customer might request some payment and these operational addresses should automatically make those payments, which means the secret key is stored somewhere which is connected to the internet, right? Which means there is risk associated with it. That is, if one of the operational addresses or operational account gets compromised, maybe all the tokens in it can be hacked or drained by some malicious user. To avoid that, you can optionally have standby addresses. These are called warm wallets, which are operated by trusted human beings, wherein most of the tokens are stored and it is mostly offline. When the token balance on operational addresses are getting low, these standby addresses can send more tokens to these operational addresses. This way you can minimize the risk of getting hacked and getting all your tokens hacked at once, because the tokens which are present in standby addresses are mostly very safe because the secret key to these standby addresses are mostly offline. Okay. So in this tutorial, I'll not be explaining about these separation of roles and stuffs like that. We will be learning about issuing the token and making payment with these issued tokens. That's the primary concern of this video. And we'll also be looking at certain commands using which we can fetch the public ledger information about these issued currencies. So that's the main objective of this video. But you can please go ahead and read all the contents present on this page for better understanding of separation of roles. So enough with the theoretical stuffs, let's get started and code something. The first step is to enable a flag on the issuing address. So let's look at that. We need to go to the transaction types and we need account set transaction type. Well, we have seen how to set and clear a flag in a couple of videos previously, so you already know how to do that. If not, please visit those and watch those and practice those stuffs before moving any further. So this is the flag we need to enable, that is default ripple, which enables rippling on this account's trust line by default. Okay, so we need to enable this on an address, and that's the issuing address for us. So let's create an account for the purpose of this video, and the account we are creating will be the issuing address. XRP faucet. Let me generate an account on test network. So this, please write down this R address, couple of letters in this R address at least, to recognize that this is the issuing address, and also the secret, because we'll be using the secret to sign, wherein you will not be able to see the R address and you can easily get confused between the R addresses and secrets. So better to write this down on a piece of paper. Okay, so let's enable default Ripple on this address. Let me create a separate file for this called token.ts maybe, because we are creating tokens, and quickly import derive and sign methods from XRPL account lib, and also the library to fetch information from the ledger, which is XRPL client. So we know we will be using family seed as secret, so we'll derive the account using family seed. Let's create an instance of XRPL client and also get connected to the test network using this WebSocket URL. We have seen all these in detail in previous videos, so I'm not explaining it in detail. Okay, I'll create a method and call it immediately, because I keep forgetting to call this and wonder why things are not working. And most RippleD methods return promises, so we'll be using async await method. And I'll start by directly writing the payload. So in a production environment, you need to fetch the sequence number from the ledger, but we already know the sequence number, so I'll directly write the payload. So the transaction type is account set, and the account information is present here. Oh wait, we haven't copied the secret. We'll do that now. We are deriving this R address from this secret. This is present inside account.address. Okay. And the fee, let's hard code it to 10 drops. That works on test network. Please fetch this information, that is current fee requirements, from the ledger. And set flag. It's 8, I know, but I want to show it to you once again. So default Ripple decimal value is 8. So set flag 8. And the sequence. Please fetch the current sequence number of the account you're signing it with from the ledger, but we already know the sequence number here. And to avoid writing unnecessary code, I'm just copying it directly from here and pasting it here. Okay, this is the payload. Now let's sign this payload using our account. So sign this payload with this account. So the derived account also has private key and public key information using which we sign the payload. We only want this field, the value of this field, that is signed transaction. So we just fetch that information. Now, using the instance client, let's run a command called submit, because we need to submit this signed transaction to the network. We have seen all these things in our previous videos, so if you're not familiar, please watch those videos and also code along with me. That way you understand better whatever I'm trying to convey you here. Okay, everything looks fine. The payload, the secret. Please, I'm telling you once again, please write down this secret and the R address associated with it. We are enabling this default Ripple flag on this R address. Okay, so let's do that. Everything looks fine. Let me execute this. Well, looks like TypeScript compiler isn't running. Let me run that first. Open another terminal. and then execute the file, that is the transpiled file present inside dist folder. So this should set the flag default ripple on our account. So let's check that. Go to some test explorers and paste this transaction hash. So default ripple has been set on this account, and this confirms it. So this is to be considered as our issuing address. Okay, now step 2 is to create a second address or hot wallet, which receives the token from the issuer. So let's do that. So I'll create second address, which also belongs to the issuer, by the way. So write this down as operational address. Please write down both the R address and the secret, and this R address and secret as issuer address. Okay, so you can write couple of letters from each R address and each secret. So clearly label it as operational address. This one is operational address and the other address is issuer address. Okay, now the second important step is to establish TrustLine from operational address to the issuer address. Okay, let's do that. Let me show the documentation for that. That is the transaction type, which is trust set. Let me get to the transaction type and trust set, add or modify a trust line. So this is the syntax. The only major difference I can see is the field limit amount, which is an object which has currency, issuer and value fields. So let's try that. So let me open up the editor, and the first thing we need to change is the secret. We are establishing trust line from operational address to the issuer address. Okay, so we need to change the secret. We need to have the secret of operational address here, because using that secret we are going to sign the payload. So let me get back and copy the secret of our operational address. This is the first thing, please don't forget this. Now the transaction type. So we know the syntax, and the transaction type is trust set with T and S capital. So we have account information inside the constant account and field address. We don't need this set flag field. Instead, we need limit amount object. So we need to specify the currency. For no particular reason, let's have the currency code as XTP. And we already know the issuer address. Let me copy it in a while. And the value. Value is the limit, that is the number of XTP, in this case XTP, you are willing to hold. So let me copy the issuer address. This is the issuer address. Please check back with your notes. If you don't write it down, I'm sure you'll get confused. We'll come up with more R addresses going further in this video. Okay. So the maximum amount of XTP, let's say 100 here. Usually the first transaction wherein we mint this XTP or issue this XTP, the value should be the maximum circulation supply you would like to have for XTP token. So for this, we shall have the value of 100. Okay. So this is the limit set by the operational address. That is, the operational address is willing to hold 100 XTP issued by this issuer. That's the whole meaning of this. I'll show this once this payload has been signed and submitted to the network. So one last thing to change is the sequence number of the operational address. The current sequence number of the operational address is present here. We need to fetch this from the ledger as well. To avoid complications of the code and length of this video, I'm just copying it from the page we just generated this operational account. So that's it. This is the payload to establish trust line between the operational address and the issuing address. So let me copy the transaction hash and check for the result. Okay, as you can see, this transaction sets the trust line with a limit of 100 XTP. If you go to the details tab, you can clearly read this. It establishes 100 as the maximum amount of XTP from this issuer that this account is willing to hold. As clear as that. Okay, so this is the issuing address. You can cross verify it with your nodes, and this is the operational address. Just cross verify it with your nodes. Okay, this finishes the second step, and the third step is to send those tokens, which is XTP in this case, from issuing address to the operational address. This is a script we wrote in our previous video tutorials to transfer XRP from one account to another account. I'll just modify the same payload and show you how to transfer an issued currency or a token from one account to another account. The amount field is an object which takes the fields like currency. By the way, you can't have XRP as currency. It will yield to an error. So our currency code is XTP, all in capitals. And the issuer, we know the issuer address. So we need to have the issuer address here and the value you want to transfer. It's not in drops. It's certainly in string, but not in drops. So let me remove this conversion from integer or decimal to drops. So this is the issuer address. Let me copy it and paste it here. Okay, that's all we need to change in the payload to transfer the IOU or issued currency or tokens from one account to another account. Everything remains same. Okay, only change is with the field amount. In case of XRP, it's a string and it should be represented in drops. For issued currencies, it is an object with fields like currency, issuer, and value. So now, since this is the first transaction to mint the token, we are going to send tokens from the issuing address. So I'm copying the secret of our issuing address. And then the destination address is the operational address, which has the trust line with the issuer. The second step, which is very important, you can't skip it. Okay, after that you need to execute it. And what if we try to send more XTP than the set limit? Okay, if you remember, the operational address has set the maximum limit to 100, right? What if you try to send 101 XTP to the operational address? Well, let's look at it. Well, the payload got submitted to the network and you have an error, and the error message is path could not send full amount and the transaction fails. Okay, so that means you can only have that much XTP or any issued currency that is set when you established a trust line. Now let's send 100 XTP. You can send 100 XTP or less than 100 XTP, that will work. Okay, the transaction was successful. Let me copy this transaction hash and check with some test network explorers. Oops, that didn't work. Let me enter here. Okay, so this is the destination address, this is the issuer account, this is the operational account, and this transaction sends 100 XTP to destination account from the issuer account. So if you click the operational account and click on this, you have XTP, that is 100 XTP. So this generated 100 XTP and 100 XTP was sent from issuing address to the operational address. So this is how you issue a token on XRP Ledger. Simple 3-step process. But we still have a couple of issues here. The first one being this issuer can freeze individual TrustLine, and then this issuer can issue more XTP to any address which is willing to hold that token, which is XTP. Of course, the willingness is expressed by establishing a TrustLine with this issuer. The first issue can be fixed by enabling no freeze flag on this issuer. That way, it can't freeze any individual TrustLines. And the second one is to disable the master key after setting the regular key to an R address which do not have a secret. So once you set these two flags on your issuing address, you lose access to this address, which means you can't issue more of these tokens. So the token supply is now fixed. That is, you have only 100 XTP. Now any other account which is willing to hold XTP should establish TrustLine with the issuer, and then this second address can transfer some XTP to that address. Okay, but now people might confuse this operational address as the issuer and start establishing TrustLine with this R address itself. To avoid such a scenario, you can enable request auth flag on this operational address, which means it requires authorization for users to hold balance issued by this operational address. Of course, this operational address has no issued tokens, so it doesn't authorize any users to hold its tokens. And optionally, this operational address could even enable deposit auth flag so that nobody else can send it XRP or any other issued currencies. That's all. These are a couple of precautions we can take before announcing our issued currency to the public. In upcoming videos, let's see how to black hole this issuing address and also a couple of public RippleD methods to fetch TrustLine information for the issuer and to regular accounts.